Hello students, in the previous class we have discussed about the pumping of sewage, right? Pumping of sewage. Okay. So and what is mean by pumping of sewage now? So we are going to pump the sewage from low level to high level, from low level to some more high level with help of a pumps, right? So when this pumping of sewage is required, we saw some 4-5 conditions, right? So whenever some part of the city is lying at low lying area and remaining major portion of the city is lying at the high level area, so we can't able to bring this small amount of sewage into the sewer lines of remaining city. So in that case we are going to pump from the low level, okay, small area to high level big area sewers, then we can treat it properly and we can dispose it to the nearby any stream, right? So next, and if there is any hill, right, if there is any mountain out of this, some area here, some area is there, okay, so we want to send the water, what is called sewage from this side to that side, you need to require a tunnel means it will cost much amount, but using pumping we can pump like this and it will go freely, okay. So like this we have another condition when the ground is located in very equal plain area, right, horizontal straight area. Here if we want to build a sewer lines with a slope, right, it requires too much excavation, okay. In this what you did now, so step by step up to here, gravity flow, pumping, gravity flow, pumping, gravity flow, like this step by step we are going for the pumping, okay. So like this, so many conditions are there for the pumping of sewage, right. Now on our next we discuss the what are the different types of pumps, okay, different types of pumps used for this sewage pumping, okay. So for that in the last class we discussed the centrifugal pump, okay, centrifugal pump, we discussed about centrifugal pump. Next we are going to discuss now what is the reciprocating pump, how it is useful to the, right, reciprocating pump, and how it is useful for the sewage pumping. Next we are going to discuss about pneumatic, right, pneumatic pump. These two are discussed in this today's class, okay. So let's start with the reciprocating pumps, okay. Now so basically the reciprocating pump, reciprocation means they are two moving in the same direction, okay, to and fro motion, right. The piston will move like this. Based on this, right, we have one inlet and one outlet, right. So whenever this piston moves this direction, this valve, this is inlet, this is outlet, right. So this valve will be get open, the liquid will be filled in the cylinder, right. Here we have a cylinder, right. So liquid will fill by opening this, right, it will fill. Then once it is coming back, this will be closed and this valve will be opened, okay. So now fluid is pressed with a high pressure so that the liquid will rise here. This is the basic principle of reciprocating pump, okay. But this reciprocating pump is having some very less application for the sewage pumping, okay. Now we will see point by point, right. Now reciprocating pumps are much less employed. These are much less employed for the sewage pumping in these days because they have high initial cost. What is the reason means? That is having high initial cost, difficulty in maintenance and greater wear and tear. We need to have much maintenance cost, okay. That's why these pumps are not at all using for pumping of sewage in these days, in recent days, right. So now next, however, in case where it is required to deal with difficult sludges and where large quantity of sewage is to be pumped, large quantity of sewage is to pumped against low heads, because reciprocating pumps may be used, okay, to a passing through 20 mm spacing. If I want to pump the sludge, okay, with a large quantity of water, okay, large quantity of water, these pumps are to be used, okay. So these are usually two types. One is ram type, another one is propeller type. We will see one by one, okay. Next, here you can see this is the normal what is called reciprocating pump. We will see in your homes, right, for lifting the water from your sump of your home to the tank at the roof level of your house, okay. So here we have a circular rotating wheel. There we have one piston like this, okay. This will move, so that this piston will move like this, one time like this, one time another. This is the inlet valve, this is outlet valve, okay. Once it is moved like this, this valve will get open, fluid will rise here, right, because of negative head create here. Then once it is going back, moving back, then this valve will be closed and this valve will be open and the liquid will be pressurized and it will move to the top, okay. So this is the basic principle how reciprocating pumps work, right. Next we will see. In the ram type reciprocating pump, a piston or plunger moves through a glands, displacing liquid in a vessel, right. So normally we will have a piston like this, okay. This is going to move in a vessel. The piston or plunger is not arranged to fit closely in the cylinder. It should not be not fitting, okay. It has to move freely front and back motion. Then the diaphragm of the pump is the diaphragm pump is an example of ram type reciprocating pump which is commonly used, okay. Among this diaphragm pump is used, okay. In the after discussing next type of, we are going to discuss about diaphragm pump, how it is work, right. Now next type is propeller. The first one is ram, another one is the propeller type. Here it is a multiple blade screw rotator. Multiple blade screw rotator or propeller moves vertically inside a pump casing, causing the sewage to be lifted. It draws liquid through inlet guide vanes and discharges through the outlet guide vanes, right. So here it is a what is called propeller reciprocating, right. So vertically it will moves into it, right. We have a two sides, okay. So like this we have guide vanes, okay. So by using that thing, that is called propeller type. Basically ram type will be used always, okay. Thus its action somewhat similar to that of the ship's propeller, okay. Ship's propeller means we have a blade in the if it is taking a ship now. So here we have a okay, some these like kind of okay vanes will be there. It will be rotate like that, okay. Next we will see what is the diaphragm. So it is a type of what is called ram type. It is a type of ram type reciprocating pump, okay. That's why he told that this is a ram type reciprocating pump. A piston or plunger is attached to the center of a circular rubber diaphragm, the outlet edge of which is bolted to a flange to a pump, okay. We have a flange, right. This is a plunger, this is a flange, right. It's attached to a circular rubber diaphragm, okay. The flexibility of diaphragm permits the up and down motion of the plunger, thereby increasing decreasing the capacity of the pump casing. We can increase the thing, okay. So during the upward movement, the plunger liquid flows inside the pump, right. So while downward movement, if it is going to, this is inlet, this is outlet, okay. So when it is going to upward movement, this in, this is out, okay. This in will be get open, liquid comes here, okay. Then downward movements, plunger will suck the thing, okay, and it will press the liquid so that through outlet it will go. So that is the thing he gave. During the upward movement of the plunger, the liquid flows into the pump through the suction valve. This is the suction valve, this is the delivery valve, right. So during the while downward movement, the plunger closes the suction valve. Here it will be closed and forces the liquid through the delivery valve, right, out of the discharge. Okay, this is the basic principle of reciprocating pump that we know. Next, the diaphragm pump is a simple, durable, needs no priming. Okay, for normally for reciprocating pump we need the centrifugal pumps we need the priming, but here we don't need reciprocal pump, need not any priming. However, if after some use the rubber diaphragm here and need to be replacement, okay, that rubber diaphragm will get tear and we need to replace it. Okay, here we can see this is the suction valve. Here liquid enters here, it will move top. Okay, so this is the plunger, right? So here I have a rubber diaphragm. Through this water will come. When it is moves up, water will enters. When it is comes down, it will be get closed and water will move, or sewage moves in the out of the cylinder to the outlet, that is called discharge side. Okay, next third type, that is air pressure pumps or pneumatic ejectors, right? Pneumatic means where we are using the air pressure. That type of things are called pneumatic pumps, right? So pneumatic ejectors are used for pumping of, lifting of small quantities of sewer. Okay, so where we will use lifting of small quantities, so you can use the pneumatic type pumps. Okay, the conditions favoring for installation of pneumatic pumps are, we will see these 3 points. Okay, the first condition, where we already know that small quantity of sewage is to be lifted from your cellar, right? So in towns we will see there will be a cellar. If this is your apartment, right? So if this is the road, we will have a cellar like this, where we can park all your vehicles now. So if rain comes now, this will be filled with water. Okay, so or you can have some drainage also here. So for that, to lift from cellar or basement of a building to a high level, that sewage will be lifted to the sewer. Next, where the quantity of sewage from a low-lying area does not justify the construction of a pumping station, right? So low-lying area, right, there will be the small quantity will be generated, right? So you need to construct the pumping station, there we will use these kind of things. Then where a centrifugal pump of small capacity like to be clogged. Okay, whenever centrifugating pump, we already know that it will going to get the clog because of the all unwanted substances will come and clog. Okay, when it is going to clog, right, what is called the centrifugal pump is not fit for the usage, there we can use this air pressure pumps. Okay, next, these pneumatic use compressed air for lifting the sewage. Okay, so we will see the diagram. Here we will have the compressed air. Here we can see the compressed air will be sent into inside, right? Okay, so here we have a counterweight. This is the counterweight. This is having low cup. Okay, this is the inlet of to the pump. Okay, so this is inlet valve V1, and here it will comes here. This is the outlet valve V2, and this is the outlet. Okay, so this is constructed with a cast iron. Okay, so it is similar to like reciprocating pump only, right? So whenever this air it will comes here, right? So the liquid will be filled up here, right? So with the help of this air, it is going to one time it will get open, another time it will get one time it will get open, another time it will get closed. Whenever it is going back, it will be open. Once coming then it is be closed and it will be opened, right? So like similar to the what is called reciprocating pump, it is going to work, right? Now here it shows a Shown's pneumatic ejector, which is commonly used in practice. Okay, the figure what you said now, so see that we are going to use. It consists of a airtight cast iron chamber with a spindle having two cups, upper cup D, which is inverted, and lower cup C. Okay, here we saw that upper cup, lower cup. Okay, this is upper cup D, inverted. This is in inverted condition. This is lower cup C. Okay, and this is made with cast iron chamber. Okay, understood? Next, the two reflex valves V1, V2 are provided at the inlet and outlet. Okay, so at inlet and outlet, this is the inlet V1, that is outlet V2. Okay, that are provided. Okay, next, at the inlet and outlet points respectively, this is okay. Next, a compressed air inlet valve V3 is provided, which is operated by a lever arrangement with a counterweight as shown in the figure. Okay, here what is telling again, we are having a valve V3. This is compressed air inlet. This is valve V3. Okay, so where the compressed air will come, and this is also fitted with a counterweight. Okay, once it is open, this will be operated. Okay, so that's what he told. Next, compressed air is supplied through this valve at a pressure of 0.15 Newton per mm square. Okay, the air in the chamber can escape through the exhaust. Okay, here we have a exhaust. Okay, so that can escape through. If it is more, no. Okay, it will be escaped through a exhaust. Okay, till now what you told now. Here we have a cast iron chamber. This is the complete cast iron chamber, and we have one cups. Okay, two piston cups. One is inverted, that is cup D. This is cup C. Okay. Next we have a inlet valve V1, outlet valve V2. Next we have a compressed gas inlet valve V3, and it is counted with a counterweight. Okay. Then he told that we have some exhaust to give a gas can escape through this exhaust. So that is the things we discussed till now. Okay. Now we will see how it is going to work. Okay. You can read one by one slowly, no problem. So the sewage flowing under gravity enters the chamber through the inlet valve V1, right, and rises slowly in the chamber, the outlet valve V2, and compressed air inlet valve B closed at this stage as the sewage level rises to the air from the chamber escapes through the exhaust. Okay. Now what happened now? So through gravity it will enters into through V1, valve V1, and will get rises to the level. Here any gas is that will be escape through the exhaust. So that is the first point he told. Next, when the sewage level reaches to the rim of the upper inverted cup D, the air inside this cup is entrapped further, rise in the sewage level in the chamber, makes the entrapped air to adjust vertical pressure on the inner bottom of the surface on inverted cup D. Due to this, the cup D is lifted up, right, and through the lever arrangement, the compressed air inlet valve F3 gets opened, and at the same time the exhaust gets closed. Okay. Now once it is open now, water will rise this. Due to this water, what is going to happen? This inverted cup will be rises. Okay, once it is rises, what is going to happen? This will be closed. This will be get open. Okay, gas will enter into inside. Okay, so due to this, cup D is lifted up, and through the lever arrangement, the compressed inlet air V3. Okay, that is not F3. That is a V3. Okay, gets opened, and at the same time the exhaust gets closed. Here it will be closed. Okay, now we will see the next what is going to happen. The air under pressure entering the chamber from valve V3 forces the sewage inside the chamber to flow through the outlet V2. Okay, once it rises, it is closed, right? Now compressed air will come inside. Due to this compression, this valve is in closed condition. Water will get pressurized, right? Water will get pressurized. Okay, so water will get pressure, it will open valve V2. Okay, that's what he told. Okay, so valve V2, and then the compressed air inlet F3, V3 are open, the inlet valve is closed. Okay, the discharge of the sewage from the chamber continues. Sewage level in the chamber falls such a point that the weight lower cup C and the sewage causes the cup C to drop. Okay. Okay, once the all liquid over, the C will come down, right? Since it is D, cup C, right? So it will come down. Then the lower cup C and the upper cup inverted cup being counted by one rod. When the cup C drops, the D also drops. Okay, we have a common line. No? Once C drops, D also will get dropped. Okay, so at the same time the compressed air inlet valve will get closed. Okay, and exhaust gets open. Okay, this will be repeated. Next, the sewage then start entering the V1 and it will completely filled up, right? So during that time V2 will be closed, right? V1 will get open, again fluid will rise, okay? Due to that D also will get rise. Once D get rise, exhaust will be closed, compression will come inside, okay? So due to the compression pressure, again CD will come down, okay? So during that time V2 will be get open, right? So this process will be continued, right? That's why only one side V1 enters filling, right? Then compressed V2 will get open, V1 will be closed, like that every time it is working, okay? To obtain nearly uniform rate of sewage flow, the ejectors are usually installed in a pairs so that when one is filling, the other is discharging, okay? Now, so to the if you want to do this, right? So here we have a one chamber only, one inside, one outside, okay? Once it is filled, then it will take time to rise. Then it has to pump, has to close. What is called compressor has to come, and this will be open. So this will take some time. That's why we have another type of arrangement. Okay, so that one will be get filled, another will be in open. Okay, both will continuously working so that we will have a continuous flow. Otherwise, it will be intermittent only. Once I have to fill, then only it will flow. Then for some time, valve V2 will be get closed. After some time, it will be get open. So there will be intermittent. Now, if you are using two now, so one is filling, one other is what is called pumping. No, so both times the continuous flow will get existed. Right. Next, the merits of pneumatic ejectors being they have no clogging parts and they work silently with the compressed air easily separated from a central station. These may be employed economically, right, for a maximum lift about 6 meters. Okay, up to 6 meters we can lift the water. Next, they also avoid the necessity of installing screens, underground suction wells. The pump capacities, however, small, varying from 500 to 10,000 liters. The principal demerit of pneumatic ejector is that they have very low efficiency, seldom above 50% working against the heads. Okay, it is having only 15% efficiency. Okay, so this is all about pumping of sewage. Okay, till now in this unit we saw what is pumping of sewage. Okay, and what is the conditions. Okay, conditions that required. Okay, that required pumping of sewage, that requires pumping of sewage, and what are the types of pumps used for sewage pumping. In that, number one is centrifugal pump, and number two is reciprocating pump, and third one is what? Very good. Okay, pneumatic pump or compressed air pump, right? So in that, the centrifugal pumps normally used, okay, that can be placed wherever you want. It will be very easy, but the problem with centrifugal pump is it will get clogged. Okay, so next, reciprocating pump. These days it is not at all used, right? So whenever high amount and for sludge lifting, we are going to use the reciprocating pump. And next, very important pump for the use of sewage pumping is pneumatic type. Okay, it won't get clogged. Okay, so and it will have no parts to be thing, but it having a very less efficiency, and it will make rise of water to up to 6 meters. Okay, so this is all about pumping of sewage and the conditions, then types of pumps. Okay, so in the next class we are going to see what is pumping station and what is the requirement of pumping stations and what are the different parts of pumping station we will see. Okay, so that's all for today. Thank you.